Hopefully you thought about which line should really got type error. Let's go over the solution. Okay. Let's now take a look at line by line. Well, not necessarily line by line. You already get familiar with the example. So I'll go directly to those lines that's worth our attention. Okay. The first line over here. Should this line be valid? Should I compile? Number one. And also number two over here. And also number three. Okay, so these are the three lines I would like to discuss. Other ones are simply just like creating objects with declaring variables. So those are not that interesting to discuss. Well, let me tell you the answer right away. So it turns out this line over here is not going to compile. But let's now go over the earlier lines as well to see why they will actually compile. The first one, you can see this b.add is calling this add method. Right, it's about storage, right? This part here, suyang, the object static type is simply just string, so that will actually be compatible with the string. A string is a descendant of string. Okay, what about here? So you can see phone number over here is a variable that was declared as a string over here, right? So you can see if we try to do this, so call by value is actually going to make sure, right? You can see this part here is going to be called by value. Is going to assign phone number to the record, right? Record is simply an object. Can you assign a string into an object? Indeed, you can, because string is a descendant class of the objects, right? Okay, so this will be valid because string is a descendant of objects. And following the same reason, if you try to look at the second one, okay, let's see over here. So let's say here we got another add method here, right? Another call to the same add method over here, just the same method. And una is a string which matches a string. A string is a descendant of string. What about birthday? Apparently, birthday over here dynamically is different, right? You can see it's the dates, and also statically it's also a dates. You can see the dates over here. So now, according to call by value, right, if you try to do the same thing over here, so we're going to do the same over here. Also call by value. So now, is birthday a descendant class of objects? Indeed, it is. So I'm just going to write over here, also string, and similarly, the dates is also a descendant of objects. So now you can see that dynamically, we're being very accommodating in terms of storage, because we can store a dates into the book. We can also store a string into the book. And dates and string, they have nothing to do with each other. So they are not related to by inheritance in any way. Right? There's no such an inheritance hierarchy that's going to involve the dates and also the string. Well, right? Okay, so now let me just make one more note over here that's also very important. So the conclusion really is, for this part here, so this is really saying, over here, any objects can be added to the book because the parameter type is simply just an object. Very accommodating, very general. That's why it's called a general book. And let's now take a look at why line number 8 will not compile. For those of you who actually thought line number 8 wouldn't compile, I wonder if you can really tell me exactly the reason. Okay, is this part over here that's not valid, or is this part here that's not valid, is this part here that's not valid, or is this part over here that's not valid, right? I want you to know exactly, right? It turns out it is this part over here that's actually not valid, okay? When you say b.get, so this dot over here is actually okay, because the static type for b is actually a book over here, and book does declare the get method, which is over here. So that's okay, right? And also una over here is actually a string value. String matches string, the parameter. So far, these two aspects are okay. But why this part here is actually not valid? That's really important to see, right? Let me use a different color. So this part is actually not good. So what will be the static return type from the get method, right? If you try to do that over here, let's see. Right, so this part here, the static return, how about let me say a little bit more formally, okay? Static type of the return value is, according to definition, is objects. Meaning that if you're trying to do this, what can you expect on the return value? Because statically, simply just an object, you can only expect attributes or methods that are declared in the object class, not the date class, not what you're thinking about, right? So b.getUna, of course, it might dynamically return the dates objects. However, the compiler again cannot infer the dynamic type for the return object. It's a undecidable problem, as we said 2 weeks ago, right? Or maybe 3 weeks ago, I forgot. Anyway, so here, this part here, the static type is simply just an object. In that case, you cannot invoke this method here. Not available. So only available on the dynamic type of the return value, not static type, right? It's very important, but what really matters for the compiler is really about the static type. So that's why it wouldn't compile. All right, so hopefully this detailed walkthrough about the problems really makes sense to you. You can think about it's just another exercise to really reinforce your understanding about polymorphism, dynamic binding, actually mainly just polymorphism. All right. Okay, so having said this, I will just switch to the next page just to say a little bit more. Okay. We know very well that b.getUna should, assuming that the implementation of the get method is actually correct and also add is correct, assuming that, right? b.getUna should return whatever birthday that's being added together with UNA. That's what we think, right? Let's say if the birthday and UNA actually are stored in this particular index, given UNA, we should definitely return the corresponding birthday for UNA, right? That's something we should really expect to happen. And if we know very well as a programmer about the dynamic type for this expression over here, how can we actually force the compiler to believe that this part over here indeed can be called upon the getDate method? Well, we need a cast, right? Let's now move on to the next page, right? I want to say that to you. Let's say for this part over here, we're going to focus one by one, okay? One by one. Let's now look at the blue one over here, just this one here. You can see this one here, we say b.getUna over here, right? b.getUna, and you can see UNA actually together with the birthday were actually added to the book. So we believe. So we believe the dynamic type for this part here, b.getUna over here. Okay, let me just write here. So we are expecting that dynamic type is a date, right? It's going to be the dynamic type, the birthday, which is a date over here. So that's why we can simply do a cast, right? And question for you, are we doing an upward casting or downward casting, right? So b.get is actually returning, according to the definition, b.get is actually going to return an object over here, right? So you can think about, we got object class over here at the top. And then every class implicitly inherits from or extends the object class, including the date class, right? You can think about the other one is also the string class. Basically, you can actually draw such an inheritance diagram for almost for every class in the Java classes, right? But we normally don't do that. It's kind of unless you really have to understand something else. Okay, so here if we try to cast the return value from objects down to the dates, is definitely a downward casting, right? So this is downward casting, and downward casting, as we know, is actually valid, right? So when we try to cast into the dates, it's a downward casting. Okay, so let's say over here it's a downward casting. So it is valid. Okay, and then once we have done the downward casting into dates, so we know that this part here, the anonymous cast. Okay, so this part over here, that's also very important to highlight. So this part over here is an anonymous cast. And what's the expression static type? It should be matching whatever cast that whatever cast class we are writing here. So which will be the dates. Okay. right? Everything is something we have said earlier, right? I'm just reminding you. Okay, anonymous cast with static type dates. So now, given that the box expression over here has the static type dates, we will be able to call getDate, right? GetDate, as I show you the API page, it is available. So now this getDate over here will just be okay if you try to use a dot notation. So that'll be fine, right? Okay, so by using a cast, by using a downward cast, we will be able to call the getDate method, right? And since the dynamic type is actually date, can the dynamic type dates fulfill the expectation of the cast type date? In this case, yes, because the dates is a descending class of the dates. It's just itself by definition. So that's good. But let's now do some follow-up. What about this expression over here? Let's say we want to say b.get suyang. So you can see this expression here. The only thing I changed was just this part, just suyang. Let's take a look at how we added suyang's entry. You can see when we added suyang, we actually added for their phone number only, right? Not really birthday. So the phone number is actually a string, literal, like a string type, right? So let's see this. So the cast will still be valid. We're still doing a downward casting. We'll simply do downward casting for objects down to string, right? That part I'm not gonna repeat, right? But what's really important for you to note is over here. b.get suyang over here. Oh, let me just draw a little bit better. So this part over here, we know that dynamically is going to return this particular string, right? So its dynamic type is actually a string, right? And then when you try to do the cast, right? The cast itself is actually going to compile, right? So now we actually go back to our 3 weeks ago, the lecture, right? Whenever you see a typecast, you want to consider whether or not it compiles, and also whether or not you will write into a class cast exception, right? So that's something I would like to say over here, okay? If you talk about this part over here, just this part, okay? This part over here is going to compile because it's a downward casting, right? We're casting from objects down to dates. Okay, it's a downward casting. Downward cast. But class cast exception will actually occur. Class cast exception. Why? Because dynamically, I know b.get suyang is going to return this particular string objects. Can string fulfill the expectation of dates? Can string fulfill the expectation of dates? No, it cannot, because string is simply not a descending class of the dates, right? Let me now annotate this more carefully. And it's really important for you to see that, right? That's something you're supposed to know from earlier lecture, but it doesn't hurt to actually brush up quickly. So this part over here is the dynamic type of this expression over here. b.get and then suyang. Okay, that's what we have. And if you're trying to cast that into dates, right? So the dates over here is a cast type in the inheritance hierarchy. This is the cast type. Right? So hopefully that's now clear to you. Casting this dynamic type of string into dates, you know that this dynamic type cannot fulfill the expectation of dates because this is not a descending class of dates, right? It's a principle we actually emphasized earlier. But how can we actually prevent such class cast runtime exception from happening? Well, we learned about the instance of operator, right? So for example, here, since this one might run into class cast exception, well, every time you want to do a cast, ideally you really want to do some instance of check just to make sure. Okay, so for example, b.get suyang over here, you can see this is some expression. Okay, so this is the left operand for the instance of operator. And I think in the earlier lecture we simply just use a reference variable as the left operand for the instance of operator. But in general, as I said before, it can be any expression denoting some objects. So this is simply some object expression, right? So in this case, what's gonna happen? This expression over here has the dynamic type string, as we just explained. Okay, so this part over here, b.get 수량 over here, this expression over here has the dynamic type. Dynamic type is actually string, right? And then can string fulfill the expectation of dates, which is the cast type over here? It cannot. So that's why it's going to evaluate to false. Okay, so the whole thing, the entire expression over here is going to evaluate to false. Okay, it's going to evaluate to false at the runtime. Right? Since it's going to evaluate to false, so that means you're not actually going to execute this particular cast, which we know is going to lead to some class cast exception. Right? It's very important for you to understand that when you have a general book, it will be very accommodating when you actually want to add something into the book, because you can add a string, you can add a birthday, you can add anything into it. You can add a product, you can add an array, you can add maybe entry, you can add maybe a vaccine site, you can add any objects into it. However, when you're retrieving something from the book, all you know is the static return type is as declared over here, which is just an object. So you can expect very little, almost none, on this particular object static return type. So that's why you cannot get away from casting to some desired type. However, whenever you do casting, you very often might just run into class cast exception if you are not actually are not being very careful about the dynamic type at that point for the objects. So that's why the safest way, if you really want to have a general book, whenever you want to do retrieval over here, is to make sure you actually do the instance of check before you do a typecast. Okay, let me write down the final remark, and then we can now criticize about the general book design. So b.get 수량, okay. So what I want to say is, for any retrieval from a general book. And here, when I say general book, I really meant the type of the elements in the record is simply just objects, right? Okay, so for any retrieval from the general book, it is required to be saved. It is required to have two things. One is the instance of checks and typecasts for every one of them in order to be saved. In order to be safe, right? You can see this is instance of check and also the cast. So these are the two things. So instance of, let me just see. So we got instance of over here and also the cast over here, right? So these are actually required to be actually will be the required constructs to write whenever you want to retrieve from the book, general book safely. Okay, so that's about the discussion for a general book. We know that it's not a very good design. It seems like, but let's see exactly why. Let me now go back to the slides. Okay. All right, I already spoke about these two slides in detail, so that's something you can also take a look about the typecast, right? Let's now take a look. So combining instance of checks and also typecasting, they seem to work programmatically. But now we want to see, do you see any potential problems, especially design problems, when with respect to the single choice design principle? If you remember a single choice design principle, that means we might just have lots of duplicates in the code, meaning that every time you want to make a single change, you may have to change multiple places to implement a change, to implement that particular change. Can you see that? Okay, let's have some hints for you. Okay, what happens when you have a large number of records of distinct dynamic types to be stored in the book? What if you want you have that? In that case, can you see any Can you visualize yourself how the single choice principle can be violated? For example, you may have dates, you may have string, you may have person, you may have account, you may have an arbitrary number of different dynamic types that can be stored into the book. Because according to the definition for the general book, you can simply just store anything into the book. All right. Think about this question over here. I'll pause over here. Think about it, and then we'll actually go over the solution with you.